everyone, we're going to use this should be deductive reasoning with laws of logic that follows from given statements. And we're going to determine if it's a law of syllogism or law of detachment. So basically, I have, I think, 6 of these or 5 of these. Here's your laws. We have law of syllogism. So this is basically here. And for the law of detachment, it's this. So these are a little harder than the ones we did previously. So if a company's taxable income is reduced by 10%, then it will go into a lower tax bracket. If the company contributes money to a certain charity, then it will reduce its taxable income by 50%. That means its original taxable income was $20,000. Because 50% of $20,000 is $10,000, and that leaves you with $10,000. All right, so let's see what this is. It's if the company contributes, we have to use deductive reasoning. So basically, it's saying if the company contributes $20,000 to the charity, then it will go into a lower tax bracket. That's syllogism. Because you have if P, then Q. So if a company is reduced by 10,000, then it will go into a lower tax bracket. It goes into a lower tax bracket than R if 50% of the amount is contributed. So basically what you're going to say for law of syllogism is if the company contributes $20,000 to the charity, then it will go into a lower tax bracket. So basically just write this down here, and you're going to say it contributes $20,000. So if I'm going to shorten this, company contributes $20,000, then it'll go in the lower tax bracket. Lower tax bracket. Well, you can write that down. All right. Now the next one is a little easier. If you park a car on a hill, then you should set the parking brake. So if P, then Q. You do park down a steep grade on a busy street. You notice how they're not saying it exactly, but you are parking on the hill. So that is true. That means Q is true. And what you would write is then you should set the parking brake. All right, and number 9 says if you take the absolute value of a positive number, if P, then the result will be that number. You do take the absolute value of a positive number, so P is true, but your positive number is a perfect square. For example, 2 squared equals 4, so 4 would be a perfect square. So that means that Q is true. And you would write the Q part is this part. But instead of saying the number, you're going to write the value, you're going to write the result is a perfect square. So you write the result is that number. But our number is a perfect square. So you write the result is a perfect square. You see where these are a little harder than the ones we did earlier. All right. Here's 3 more. If the ice on the lake becomes brittle, it may not be safe to walk on the ice for up to 24 hours. So if P, then Q, if there's a large rapid decrease in air temperature, then the ice becomes brittle. So this one is if there's a large rapid decrease in air temperature. So you're going to write this first. And then you're going to write, then the ice on the lake may not be safe to walk on. So then you write this part for 24 hours. So this is the law of syllogism. It's just kind of, it's worded, it's taken, it's kind of written backwards here. So if P then Q then R, then we have if P then R. So our P is this part. This is the part you're going to write down. I don't want to write it here because you can read it here. And our R is this part. So basically it started here. If P then Q, then we had then if Q then R. It was written backwards. All right, next one. If an object has a greater volume than an equivalent mass of water, then the object will float in the water. The ball has 3 times the volume of equivalent water. So basically, this is the ball will float in water. All right. So this is detachment. We have if P then Q. P is true. Therefore, Q is true. So this is your P has a greater volume. These two kind of go together. The object will float in water. We're not going to write the object will float in water. We're going to write the ball will float in water. Okay, the last one is this one. If a car is moving at a speed of 50 miles per hour, then it takes 175 feet to stop the car on average. The car is traveling 50 miles per hour when another vehicle pulls directly in its path. So what you're going to write for this one is the car will not be able to stop in time. So in time to keep it from hitting the other vehicle. So that's your statement, and this is detachment. So basically, if it takes 175, you have to think about this one. If it takes 175 feet to stop the car on average, and if the car is traveling at 50 miles per hour when another vehicle pulls in its path, it won't have time to stop. And that's law of detachment. So that's it. Thank you. Have a nice day. Bye-bye.